All right, so this guy right here is still working on it. Decided I'm going to convert it over to dual resonant. So I basically had to buy 100 capacitors. I got them for pretty cheap, but I'm going to try to make an MMC out of those to try to get the current. Otherwise, I just, not able to find caps that are going to be able to handle the peak current. I kind of cleaned this up a little bit. The original throw together I had a bunch of gate resistance on the full bridge and for the buck switch. But then I realized even with the drivers I've got, it's just not able to push that current fast enough. So I've basically dropped down to like no gate resistors on there. There's no ringing or anything. So I started building another buck. So I'm probably just going to build another one. And then I started entertaining the idea of using a GDT just for the single switch to get some negative drive and full isolation. But then I kind of thought about how, well, I would need some kind of, DC restoration on the output because, you're not dealing with a 50% duty cycle. If it's not 50%, your DC bias is going to be all jacked up. So actually what's kind of cool is what will happen is if I were to just use this like this with no DC restoration, then the on times of the square waves are basically going to show up on your scope. You're going to start sort of forming the shape of a ramp, right? Because your offset's going to start shifting around. It's not going to have a solid 0 volt reference. There is a way to sort of clean that up, but I did like how this little GDT works. This is a little tiny GDT. It's got two secondaries on it. So this would be good for driving a half bridge. Got this off Mauser. Pretty cheap. I might use something like that in the future, but it's real fast, real clean switch right there. Real clean signal on your gate. So this will probably end up just being a half bridge. I'll turn this into just a whole driver itself and add a few more things. I'll probably just go back to, I might throw a 14 amp switch on the next one just to drive the buck switch on that. So again, this is going to be sort of another one, just like this, using that kind of switch. And that'll be the one I'll eventually use these for. But once I get that one switched over to dual resonant, I get it all set up, then I'll probably swap that bridge out. And I'll try to reuse that full bridge for something else. Like, I'm actually kind of liking that Brian's from Side 2 HD, his high power induction heater, right? So I might try to make one of those and slap those big switches on this huge heatsink that I've got. Throw some big old fans on it. And also, still got this other one here. So I've actually put a 4S battery on there now. Basically just run all that from the battery, right? Runs quite some time. And just keep using the push button, right? So that's still a pretty good deal. Never really condensed it down anymore. I don't know if I'm gonna. But yeah, that works great. But with this one, when I get it dual resonant, I'm gonna have to use a much higher impedance primary, something like that. Real small MMC value. Low battery. Get that going. 24. And so I'm gonna back the amplitude down a little bit. That's the lowest on time. So you can see that's about 100 right there. You can see it's kind of, you could really see the 300 kilohertz coming out in it. Cut the on time up. So cut the on time up, gets rid of some of those branches. And see it's starting to slope. Further I cut it up, that's all the way up. It's fairly fat. all the way back down. So something about like that on time seems all right. So now it's starting to do that little pop thing every now and then. I'm just a little bit over about 110 on the ramps. So they're not bad. I can tell that probably what I've got still is sort of streaking issues from that pop that comes in. But if I was to keep going up in the voltage, it's out. Look, yeah, those streaks. If I keep going up in the voltage, so that's the ramp right there. So it's really not that much over 100. So the thing is, I kind of like the tuning on it, right? But I'll either have to like super insulate that primary a little better or like move it down some more, but I don't really want to move the coupling down anymore. But yeah, so again, just kind of tweaking that around a little bit. It actually looks pretty good at 300 kilohertz. All right, here goes this one. Just got a 4S battery. And the way that worked out is that's about the max I wanted to feed this 55 volt FET ZVS charging circuit. So it's all running off the 16.5, just barely getting about 15 on the gate drivers for here. So basically the inherent issue is, you know, once you start draining it down too much, I'm going to have under voltages going on here. But, you know, theoretically it should still actually run. Everything should still run once it even gets down to like 12 volts. 13, right? So it's going to have to drain quite a bit of current down before it reaches that point. But just keeping a visual check on it with the voltmeter, right? So easy peasy. We got a ramp generator going to it, and that's it. Got the looking at the waveform of the ramp as well. So basically, with that on and the ramp going, I'm just gonna charge up the bus using this push button, right? So if I wanted to have it always going, I could just hold the button down, you know, but again, this saves power. I'm not trying to drain that battery super fast. And trying to catch the ramps on there. So that's peaking up to about, 110, 120 tops. It's not actually reaching too much over that. Alright. And that's with the on time up a little bit. So now, yeah, now I can get closer to like 120, 130 if I charge it all the way up. But also cut the amplitude up a little bit because I had it turned down. So that's basically with the amplitude all the way up and me charging it up, letting it basically reach full charge of how I've got it set. So you can see it does reach out pretty good. Let me see. Cut the on time up quite a bit more. Still looks pretty good, just get a little fatter. All right. So yeah, I like that setup. Just overall pretty nifty. So probably what I should do is just put the ramp generator on board, right? So that will drain that battery. You're not going to be able to run it forever, but you know, I can probably get a good 30 minutes of play time to an hour or something like that off that battery. Again, that's a pretty small 4S battery. That's yeah, 2200 milliamp hour, right? So not bad, but this general setup again doesn't need to be that big. I'm just too lazy to really rework that whole thing. I'm like, screw it, I'll just do another one later. But it's a pretty decent bridge build. Again, those are the 247 package 60 and 65 IGBTs. Just basic full bridge, couple of UCC gate drivers, Schmitt trigger feedback, and that's pretty much it. So one thing that I actually could do on this setup is actually add a basic phase lead. So I might end up doing that. It might be able to improve the output even more. But again, that's just secondary feedback. Got a series capacitor. It ends up coming up to about 110 nanofarad, something like that. So it is helping that tune a little bit. Yeah, but again, just really cool setup. Just all battery contained. Just need that ground hooked up.